Muy bien, nuestra siguiente ponente.
Our next speaker is called Almudena Martín Castro. She has a degree in fine art. She's a professional pianist. And then she got bored, so she decided to get a degree in physics as well. And she's written a wonderful book about Pythagoras. Now, we're going to be talking a little bit about people who didn't like Newton very much, and we're going to talk about the different threads of the rainbow. So a warm round of applause, please, for Almudena Martín Castro. Does not everything fly for the touch of philosophy? What about rainbows? Rainbows are there, we know their texture, you know their colour. Philosophy will clip an angel's wings, conquer all mysteries by rule and line, empty the haunted air, the gnomed mine, and weave a rainbow, as it erewhile made the tender-personed Lamia melt into a shade. Now, that is perhaps one of the best known verses written about science. It's not a great verse, right? It's not very optimistic. It was written by John Keats in 1820, and it talks about a mythological being, a lamia, which becomes a woman and then a snake. But Keats here isn't actually talking about philosophy. He's, just getting a little bit entertained in order to slag off Newton's optical theory. That's basically what he's trying to do here. Because he was saying that philosophy was going to get rid of all the mysteries of the rainbow. And he really, really didn't like Newton. Because years after writing these verses, when he was hanging around with some other friends and other poets, he made a toast and he said, "Newton's health and confusion to mathematics." But the thing is that Keats wasn't the only one to think like that. And during Romanticism and the revolution of science, science had revolutionized the way people saw the world. And many Romantic thinkers blamed science for having destroyed the magic of nature. They accused them of trying to manipulate nature to turn it into an automaton. I'm generalizing, of course. There were many poets who praised science. And there were scientists, for example, Humboldt, who became real symbols of Romanticism and inspired many, many works of literature. But it's true that Romanticism criticized this whole emphasis on rationale and rationality, which the Enlightenment had brought with it. And often it portrayed science as a kind of reductionist movement, which presented the world as something mechanical, in which there was no room for emotions or beauty. So the question is that true? Does science really destroy beauty? Well, the opinions of Keats and other of his contemporaries aren't that important, really. It could just be, some poets, some things said by a poet who's been dead for a couple of hundred years. But science has its roots in that very same era. The way in which we think, popularly at least, when we're assessing an artistic piece of work, come from Romanticism, and this stereotype that we have of scientists also comes from that era. This idea that we have of scientists as being very cold statues, sort of machines who are just relentlessly pursuing truth. Now, I know that people here probably don't think that, but the stereotype of a physicist and a mathematician tends to look at them as figures that are very cold. And the roots of that are in Romanticism. When I was a teenager, I remember that I thought that science and mathematics was very creative. You're just moving numbers around on either side of an equation. And that was part of the reason why I went to right the other extreme and to study fine art. to try to find this creative ideal, again, which has its roots in Romanticism. So when I decided to study physics, I was really surprised to find that in my second degree, physicists were saying, oh, it's so beautiful, it's so fantastic. And they did that a lot more often than my teachers who were teaching me fine art. They were no strangers to that wonderful emotion of being amazed by beauty. And years later, I discovered that many physicists, and in fact Nobel laureates, and in fact we've seen this over the past few days, have actually been really interested in aesthetic questions and beauty, and they express this emotion that they feel when they feel and they discover mathematics in the world, when they're describing that tiny piece of reality using mathematics or using physics or whatever. But this beauty isn't perhaps a typical kind of beauty. It's not visual beauty maybe, and it's not a beauty that's sort of similar to the beauty that inspired the poets of the Romantic era. It's a beauty that has a lot more to do with patterns and symmetry. Usually, it's characterized by a lot of simplicity with a very high degree of explanatory power. It's just like when the pieces fit and there's suddenly harmony. You remember, when you're at home and, you get your USB stick in right the first time, you think, oh, that feels really good. Well, it's like that. When you've got lots of pieces of a puzzle and all of a sudden they all fit together and there's this wonderful sense of harmony. Now, many of you who are here today will be familiar with this type of beauty, I'm sure. But I'm here to talk about the greatest beauty, the rainbow. I mean, look at rainbows. Even when it's explained from a scientific point of view, a rainbow continues to maintain its poetic power. So, I'm going to try to explain that to you now. I wanted to bring Newton here to explain it to you, but he's been dead for a while now. So I'm going to try to explain it, and you can decide whether you think that there's poetry in the explanation as well as mathematics. So what is a rainbow? Well, Descartes described it in the 17th century, and it's how sunlight is reflected in each water droplet. So sun rays arrive parallel to a curtain of raindrops, and they're reflected inside these drops, and they're reflected but always with the same deflection angle, 42 degrees. And these 42 degrees, they are just scattered. All the colours are scattered. This happens at all raindrops, at all heights, and not just on the same plane. This is a gross simplification. It would be more like a circle for each raindrop. But when we see it and we view it from afar, and when you ever see a rainbow, you will have the sun behind you. Your shadow will always be in front of you. And these sun rays, as they hit all these different drops, and our eyes just see some of them. Which are the drops that we see? Those that are located 42 degrees around your eyes and the sun, the rays of sun, which in that particular angle. It doesn't mean that the rest of the drops aren't reflecting the colours. It's just that our eyes act as a filter. They attract or they trap those colours, so they only see some of the raindrops that are up there in the sky. But how fantastic is that? I mean, how gorgeous is that? All rainbows are liquid. They're just, droplets that are falling down. And all the rainbows that we see are unique in the sense that each one is born and dies in a blink of an eye, in the blink of the eye of the person who's seeing them. And this is what I came here to tell you today. I hope I have convinced you that an explanation doesn't kill the beauty of a natural phenomenon. And I would just like to finish with a quote from Feynman, who said something like this: poets say that science robs stars beauty, but that's not true. I can see stars on a clear night The vastness of the skies extends my imagination. I can see light from over 1,000 years ago. It does not do harm to the mystery to know a little about it. Far more marvellous is the truth that any artist of the past imagined it. Thank you very much.